3, 4, 5 C's in a row.
In the past, finding genes that cause a disease was a painstakingly slow process. But with the completion of a list, it should be much easier to make a direct connection from disease to gene. But how? Well, let's say I'm looking for a gene that causes something. We'll make it male pattern baldness. How would I go about that? Well, I'd want to get a bunch of bald guys. So here are 3 bald guys, and take their blood and look at their DNA. Now I'll take 3 guys with lots of hair, and here is their DNA. And what if the bald guys all share a particular spelling right here in this spot, which we will call the bald spot, and at the same spot, you notice the hairy guys have, see that, a different spelling. So, is this the gene that causes baldness? Maybe, but probably not. This could be a coincidence. So, how do I improve my chances of finding the specific spelling difference that relates to baldness? It would help if I knew that the bald guys and the hairy guys had really similar DNA, except for the genes I suspect may make them bald or hairy. Where do I find guys who are very, very similar with, a few exceptions? A family, right? If there were brothers and fathers and sons and cousins, for instance, who share lots of genes. So let's say these 3 guys are brothers, astonishing similarity really in the face, but notice that one of them is hairy and 2 are bald. Whatever is making this one different should stand out when you compare their genes. And same for these guys. There's a difference clearly in the photos, but that difference may turn up in the genes. You can do the same thing for any disease you like. So if I could comb through the DNA of lots of people who are related, and I find some of them are sick and some of them are healthy, I might have a much better chance of figuring out which genes are involved. Well, where do I do this? Well, one place is a little island nation in the North Atlantic, Iceland. In many ways, Iceland is the perfect place to look for genes that cause diseases. It's got a tiny population, only about 280,000 people, and virtually all of them are descended from the original settlers, Vikings, who came here over 1,000 years ago.
If you drive around this country, you will have great difficulties finding any evidence of the dynamic culture that was here for all these 1,100 years. There are no great buildings, there are no monuments.
But one thing Iceland does have is a fantastic written history, including almost everybody's family tree. And now it's all in a giant database. Just punch in a social security number, and there they are, all your ancestors, right back to the original Viking.
So what we have here is my ancestor tree. I'm here at the bottom. This is my father and mother, my grandparents, great-grandparents, and so on. We can find an individual that was one of the original settlers of Iceland. Here we have Chpt Bjarnason, called Ketill Flatnefur, meaning he had a flat nose, so he may have broken it in a fight or something. And we estimate that he was born around the year 805.
Kari Stephenson is a Harvard-trained scientist who saw the potential gold mine that might be hidden in Iceland's genetic history. He set up a company called Decode Genetics to combine age-old family trees with state-of-the-art DNA analysis and computer technology and systematically hunt down the genes that cause disease.
Our idea was to try to bring together as much data on healthcare as possible, as much data on genetics as possible, and the genealogy, and simply use the informatics tools to help us to discover new knowledge, discovering new ways to diagnose, treat, and prevent diseases.
One of Decode's first projects was to look for the genes that might cause osteoarthritis. Reinheiður Magnúsdóttir had the debilitating disease most of her life.
The first symptoms appeared when I was 12, and by the age of 14, my knees hurt very badly. No one really paid any attention. That's just the way it was. But by the age of 39, I'd had enough, so I went to a doctor.
Mrs. Magnusdóttir was never alone in her suffering. She is one of 17 children. 11 of them were so stricken with arthritis they had to have their hips replaced. This was exactly the kind of family that Decode was looking for. They got Mrs. Magnusdóttir and other members of her family to donate blood samples for DNA analysis, and to find more of her relatives, people she'd never met, Decode just entered her social security number into their giant database, and there they were. But which of these people have arthritis? To find out, Stephenson asked the government of Iceland to give his company exclusive access to the entire country's medical records. In exchange, Decode would pay $1 million a year plus a share of any profits. That way, Decode could link everything in their computers: DNA, health records, and family trees.
This idea was probably more debated than any other issue in the history of the Republic. On the eve of the parliamentary vote on the bill, there was an opinion poll taken which showed that 75% of those who took a stand on the issue supported the passage of the bill, 25% were against it.
Among that 25% against the plan were most of Iceland's doctors.
I felt that there was something fundamentally wrong in all of this, you know. They do know everything about you, not only about your medical history, about your medical past, but they do have your gene, the DNA. They know about your future, about something about your children, about your relatives.
We find ourselves paralyzed because there is really nothing we can do, because the one who takes the responsibility is the management of the health center. If they give away this information from the medical records, they get money, and everybody needs money. Health care really needs money.
So what's really the problem here? Well, let's take a hypothetical example. I'm going to make all this up. Let's pretend these are medical records of an average person, and we'll suppose that right here I see an HIV test, and then over here is medication for anxiety after what appears to be a messy divorce. And over here, a parent who died of Alzheimer's. Now, this is all stuff that could happen to anybody, but do you want it all in some central computer bank, and do you want it linked in the same computer to all your relatives and to your own personal DNA file? And should anybody have the right to go on a fishing expedition through your medical history and your DNA? Well, it may be frightening, but it also might work. Decode claims it's discovered several genes that may contribute to osteoarthritis. So this approach, combining family trees, medical records, and DNA, could lead to better drugs or to cures for a whole range of diseases.
To have all of the data in one place, so you can use the modern, informatics equipment to juxtapose the bits and pieces of data and look for the best fit. It's absolutely fascinating possibility.
Stephenson says no one's forced to do this, and there are elaborate privacy protections in place. No names are used, social security numbers are encoded. He also argues that the DNA part of the database is voluntary.
The healthcare database only contains healthcare information. We can cross-reference it with DNA information, but only from those individuals who have been willing to give us blood, allowing us to isolate DNA, genotype it, and cross-referencing it with the database. Only from those who have deliberately taken that risk. So it's not imposed on anyone. And no one who is scared of it, no one who is really afraid of it, should come and give us blood.